Hi, welcome back. We're going to go over lesson 3.3, the protractor and angle measure lesson. So we're going to start with postulate 4, which also has the name the protractor postulate. When you're doing your homework, I usually just refer to it as postulate 4. Let me read it to you. It says the rays in a half rotation can be numbered from 0 to 180 degrees so that positive number differences measure angles. All right, so this is just a really complicated way of saying we're gonna measure, angles with a protractor, which is something you've been doing for years. So it talks about rays in a half rotation. Well, a half rotation, that's like a half of a circle, which, I just drew it out here, which looks like a protractor. And we have rays that go from 0 to 180. So, that's just how a protractor would look. You're going to measure it. Now, the difference is you're not going to be able to rotate the protractor to put the 0 on one of the sides of the angle. So we're going to figure out how to do this. It says positive number differences measure angle measures. So that means you can never have a negative angle measure. Measurement is always positive when dealing with angles. So if this angle here is at 30 and this one is at 120, positive number differences. Differences means you're subtracting. And obviously, if you subtract like this, that doesn't make sense because can your answer be negative 90? No. So either just take the absolute value of it or start with a bigger number and subtract to get your answer. Okay. Anytime that you are doing a proof and it wants you to justify an angle measure, you're always going to reference the protractor postulate. Now, things that we know, now I wrote them as biconditionals because technically all definitions are biconditionals. Acute means it's more or less than 90, but more than 0. A right angle is when it equals 90, and obtuse when it's more than 90, but technically it's less than 180. And straight is when it equals 180. Now, again, don't make it more difficult than what it is. A straight angle looks like a straight line, okay? So we know a straight line has 180 degrees. It's just a ray that goes to the right and a ray that goes to the left. Moving on. When you have a protractor like this, we're gonna just subtract and get the answer. That's it. KAE, so connect the dots. KAE. You're finding this measure right here, which my answer should be less than 90 since that looks acute. Okay, so either use both the top numbers or both the bottom numbers. You really never want to use one top number and one bottom number because you'll end up getting the wrong answer. So for consistency's sake, I'm going to always use the top number. So I have 130, which is the largest number, and I'm going to subtract the 70. So I get 60 degrees. And that's it. That's all you have to do. Let's find the measure of DAN. DAN. Okay, so now I know sometimes the line goes through the number, and if it's hard to read, look at the number, on either side to help you judge. So this is 160, and if you just look at this, that kind of looks like a 50, but if you look at both sides, that has to be a 90. So my answer is 70. Okay, next one, KAD. KAD. All right, we're going to find the measure of this angle. So it's 160 and 70, which is 90. All right, let's go back. We know the first one is acute. The second one is acute. This is a right angle. And let's find the last one. BAD. Lots of acute angles today. 180 minus 160 is 20 degrees. And again, this is acute. Now, on these, there's not going to be any margin of error because you're just subtracting. Again, something that sounds really difficult, but it's not. Let me explain. You have 4 rays in a half rotation. So we understand what this means now. Half rotation is like a protractor. And we're going to just kind of draw these in. And this is a sketch. Okay. So when you have to do this on your quiz, don't get a protractor out. You're just sketching. I'm going to say 0 is here and 180 is here. So I'm going to judge where ray AB would be. And so it's very small, and that I'm sure I overshot that. So let's label this. A would be here, B would be out here somewhere, and then the measurement is 3. I'm actually, my eraser went nuts on me. Okay, so I'm going to put the 3 here and the B here. All right. AC. So it would be, and again, I'm overshooting this. AC, and the measure's 32. Now, straight up would be 90, so let's go this way. AD, and the measurement's 81. And then over here somewhere is A to E, and it's 145. Okay, now technically you don't have to draw the protractor thing in if you understand. Okay, so this is how the book would show it. The little protractor thing, for some reason, really helps every year. So do whichever way you'd like. Now, it says find our name and find the measures of the angles. Okay, so there's really lots and lots of angles here, and we could do this all day, but we're just going to pick out a few of the angles. So let's change colors. What is the name of this little angle? Well, since it's labeled, we know it's BAD. Or, I'm sorry, BAC. Or go backwards, CAB. Remember, when naming angles, the vertex has to be the middle letter. So every time you see this, the middle letter should be A, which is your vertex. To get my answer, I'm just going to take 32 minus 3 to get 29 degrees. Easy enough. Okay, let's find the name and measure of this angle. Now, 2 ways to write it. You could say DAC or CAD. CAD. I just choose one randomly. There's no rhyme or reason. All right, 81 minus 32. All right, 81 minus 32 is 49. Let's find this next big angle. So let's name it DAE or EAD. And 145 minus 81. So I get 64. Now, technically, we could combine some of these together if we wanted to. I'm just going to do one of those. Let's look at BAD. Because, technically that's an angle. And we could do this a lot with this lesson on this problem. But let's just do one more angle, BAD. So let's use the 2 coordinates, 81 and 3, which is 78. All right, betweenness of rays. Okay, now all it is you're taking 2 little angles, adding them together to get a bigger angle. This is theorem 2. A great example of this is what we just practiced on this problem. We had this little tiny angle 1 with this little tiny angle 2, and we combined them together. And that's how we got the 78. The 2 little measures added up together. Okay, so little angle plus the little angle equals the big angle. Again, a lot of things with geometry sound much more difficult than what it is, because when you see this, it's like, what does that even mean? Technically, these are rays, and we don't know how big or small the rays are. I'm just going to draw a sketch. So you have ray OA, ray OB, and ray OC. What it is saying that if you have this situation, you can take this first angle and then the next little angle. So little angle plus the little angle, and it's going to equal this big angle, which makes sense. 2 little angles together form a bigger angle. So I'm just going to throw in some measurements. So if this little angle is 40 and this little angle is 50, what's the measure of the big angle? And of course, you know that is 90. All right, so let's apply this. Find the measure of KLM. KLM. If KLB is 26 and BLM is 60. So angle, it's theorem 2. If you have a tutor, usually this is called angle addition postulate. Your book calls it something different. It's the same thing if you want to look that up to get extra practice problems. Okay, so little angle plus little angle equals big angle. So 26 plus 60 equals 86. Of course, that one was too easy. Let's try the next one. VUT. So when it's the entire angle, I always put a big arc like this to help me realize what's going on. So the measure of everything is 175. The next one, VUJ, is 17x minus 3. And then the other little angle is 17x plus 8. Okay, now this is a little more complicated. We're going to say the first little angle plus the second little angle is going to equal the big angle. And we're going to do this with algebra. We're going to write an equation. Okay, the first little angle. Actually, let's write this out with the names first. So I have angle VUJ plus angle, this little angle, JUT equals the big angle, VUT. So little plus little equals big. So let's plug in our values. 17x minus 3 plus 17x plus 8 equals 175. Let's combine like terms. So 17 plus 17 is 34. X. 8 and negative 3 is 5. Subtract 5. 34x equals 170. So 170 divided by 34 is 5. Okay, so we solve for x. Now sometimes it may ask you to plug it back in to find the actual measures of the angles. And we know that once you plug it in, the two should add together to give you your total of 175. All right, let's try another one. GFN, GFN. So it's this little angle, 4x plus 10, and then NFE, 14x plus 3, and then the big angle, notice how I put the big arc so everyone knows what's going on, is 157. Okay, so little angle plus little angle equals big angle. Let's write out the names first. GFN plus NFE equals GFE. Let's put in the values. 4x plus 10 plus 14x plus 3 equals 157. Let's combine like terms. 18x plus 13 equals 157. And subtract 13. 18x equals 144. So let's grab a calculator. 144 divided by 18 is 8. Now, notice it doesn't really even say solve for x. It says find the measure here. So to find the measure, we're just going to take the 8 and plug it back in. So we have an equation for NFE. So that is NFE is 14x plus 3. So let's just plug in the x. All right, calculator time. 14 times 8 is 112. Plus 3 is 115 degrees. Okay, so your assignment is your online lesson 3.3. And then when you're finished with that, you have unlimited attempts. You can join me for a session at the end of your class. So I get back on Teams at 2:40. So jump back on and ask any questions and then take your quiz. As always, you have unlimited attempts on this assignment. All right, thanks.